Right, let's take a look at this example. There are three parts to it. Let's do one part at a time. You are given the position vector of 3 points, A, B, and C, and there is one unknown lambda here. Right, the rest are known. The first part doesn't require the use of the solving of the lambda. The first part basically asks us to find the unit vector in the direction of AB. Let us recall, before we recall how to find direction, your unit vector, it's not difficult to say, okay, AB is OB minus OA. We solve and we get this vector. You could either leave it as it is, like that, or like that. It is actually fine, but um, if we can factorize the 3, just factorize the 3. If not, you could have left it as that as well. Either or is perfectly acceptable. But now that we have found AB, you want to find a unit vector in the direction of AB. Not just AB, but a unit vector. Let us recall what is a unit vector. A unit vector essentially is a vector in the same direction as that vector, but the magnitude is 1. I repeat, magnitude is 1. So to find the required unit vector, you recall this one. You basically take the vector, divide by its magnitude. Divide by its magnitude. So first we can then, to find the unit vector, we say, okay, the unit vector of AB is essentially AB divided by its magnitude. Okay, so I want all of us to recall this formula that you are given. Okay, if you need to recap the idea of unit vector, go back and recap. Okay, so that's that. Let's take a look at the next part. Find the value of lambda such that A, B, C are collinear points. Let us recall what is collinear. If 3 points are collinear, it means they lie on the same straight line as what you can see here. Okay, they lie on the same straight line as what you can see here. In order to prove, you are given that ABC now are collinear, it is quite easy to say, therefore, that AB and BC are surely parallel. Right? You can see this from this diagram. AB and BC are surely parallel. So AB and BC must be scalar multiples of each other for some alpha, where alpha is unknown. Quite clear. Okay. Now, from earlier, from part 1, you have already found AB. Okay, from part 1, you already found AB, which is this, -3, 12, and 6. This is given. Okay. What is BC? BC you can also find, which is actually OC minus OB. And everything will be in terms of lambda, which is an unknown here, which is fine. All right, which is fine. Now, since A, B, C are collinear, we can definitely say AB equals to alpha BC. So I'm going to write it out now. Okay, since this is true, then I can say, okay, -3, 12, and 6 must surely be alpha times of lambda -1, -4, and -2. How do I get that? I get from here to here because I substitute all this one into BC. AB actually is this. And it's all arose from the idea of collinearity, as you can see from this diagram. So in itself, you can see what I've written here. It looks like one equation, but actually there are 3 equations because there's the x component, there's a y component, and the z component. So I can actually have 3 equations written out like that from the first line, second line, and third line. Now, if you can see carefully, if you look at this line as well as this line, they give the same result. Yep, from 2 and 3. Actually, if you solve 2 and 3, you will get one solution. Alpha must be -3. Right? And then you substitute into 1. You sub alpha minus 3 into 1, you get, therefore, you get minus 3 equals to minus 3 lambda minus 1. Lambda must be equals to 2. There you solve it. Okay, here I'm just using the idea of collinearity. Okay, let us recap. I'm using the idea of collinearity here. Last part. Now, given that lambda is minus 2, just now you show that you found lambda is 2, you erase that one, lambda is minus 2 now. Find the position vector of D such that ABCD is a parallelogram. I draw a parallelogram here for all of us to see. Okay, right, parallelogram. And we learned the properties of parallelogram earlier. Okay, for ABCD to be a parallelogram, okay, can I then safely say that this vector AB must be equals to this vector DC? I say vector, I'm not saying length only, I'm saying vector because in a vector there are two parts to it. One is the direction, parallel, and magnitude. So this is the idea that I'm going to use. Okay, if ABCD is a parallelogram, AB vector equals to DC vector. Okay, and which means this. All right, AB vector equals to DC is actually OC minus OD. This one is a given, right? DC is actually OC minus OD. Now rearranging this one, you can make OD the subject is actually OC minus AB. Now what is OC? OC is something that you know because OC is just 1, 3, sorry, I beg your pardon. OC is just lambda is minus 2, minus 1, and 3. Right, this is OC because this is OC and lambda is minus 2. What is AB? AB is what you found earlier. AB is from part 1 you already found AB. Minus 3, 12, and 6. Therefore, answer very simple. Answer is 1, minus 13, as well as minus 3. So I just want to emphasize us using the idea of parallelogram. If ABCD is a parallelogram, then the opposite two sides, the opposite two vectors must be equal. Equal means, when I say vector equal, means direction as well as magnitude. So that concludes this example.